Important facts about finite automata and regular expression. The length of a string in finite automata, the length of a string, suppose n, then the minimum DFA should have n plus 1 states. The length of the string, this is the length of the string. If we have length of string n, then the minimum DFA will have greater than or equals to n plus 1 states. How? Let's understand with example. Suppose we have this DFA with a string. So number of string is length of string is 1. So there is 1 start state and 1 final state. So there is 1 start state, 1 final state. Length of the string is 1. So what we can say? We can say DFA is greater than or equals to length of the string 1 plus 1. Length of the string is 1 and we have 2 states. One is start and one is final. So that is 2. So DFA is greater than or equals to n plus 1. That is n and that is plus 1. So DFA is having greater than or equals to n plus 1 state, and one more state is also required because this is DFA. Why? One more state is also required, that is called trap state. So total, that is called trap state. So total, how many states a DFA have? DFA have 3 number of state. So definitely DFA is always greater than or equals to n plus 1 because here n is 1 and so DFA is greater than or equals to n plus 1. This proves here. So we can simply say minimum DFA is having 3 number of states, while NFA is having 2 number of states. Minimum DFA is having 3 number of states, while NFA is having 2 number of states, because in NFA trap state is there is no trap state, because in NFA we don't have any trap state. So we can say minimal NFA and minimal DFA, minimal NFA and minimal DFA are not unique, but only states are unique. So we can say minimal NFA and minimal DFA are not unique, but only states are unique. So simply DFA is n plus 2 and NFA is having n plus 1 states. From here it is clear DFA is having n plus 2. Here n is 1, so n plus 2 states, and in DFA, but NFA because trap state is not there, so only n plus 1 states. So DFA is having n plus 2 states and NFA is having n plus 1 states. For minimal state NFA, first we need to make minimal DFA and then remove and then remove. For minimal state NFA, first make minimal DFA and then remove trap state and then remove trap state or dead state. This is the way we can find minimal NFA. This is not an algo, but this is the way we can follow and we can get minimal NFA. And by regular expression we get minimal state. By regular expression we get minimal state NFA, but cannot get DFA. By regular expression we can get minimal state NFA, but we cannot get DFA. These are few things which are very important. And now move to the next. What next? Sorry. There is no trap. There is no trap for mod machine. There is no trap for mod machine. Suppose let's understand with example. The first, even number of A. Even number of A, we need to make a mod machine for this. Mod 2 is equals to 0. Mod 2 is equals to 0. Why? Because this is even number of A. So how we are going to make it? We can simply make like this, because this is even number, so initial state will be the final state and even number of A. So like this we will have, and we will put B loop here and put B loop here, because B can be odd or even both. It doesn't matter, it only matter for even number of A. So this is the mod machine. Mod 2 is equals to 0 because this is even. Now the second is for odd number of A's. For odd number of A's, so the length of the string mod 2 is equals to 1. Mod 2 is equals to 1. Why? Because this is for odd number of A's. So how we are going to make it? Simply going to make it Q0 Q1. Now Q1 will be the final state because we need odd number of A's. So simply B can be, we can put like loop because there is no restriction on B. So simply B. So first when it will run first time, then 1A, then second time, then 3A, then third time, then 5A, like this it will go. So this is a mod machine for odd number of A. So that's why 2 is equals to, mod 2 is equals to 1, because this is for odd number of A. And mod machine are cyclic. Mod machine are cyclic. There are few important terms about regular expression. So now move to the next few important terms about regular expression. What we have? The precedence level. What we have? These are the precedence level for regular expression. The first one, the second one, the third one, and the fourth one. These are the precedence levels in regular expression. Precedence level in regular expression. The first one is the bracket, then star, then dot, then plus. And the second thing regarding expression, intersection and the complement are not allowed in intersection and complement are not allowed in regular expression. Now move to the next. Suppose we are going to make the regular expression for mod 3 is equals to 0. Regular expression for mod 3 is equals to 0. So how we are going to make it? We simply make it like this, where alphabet is AB. So we are going make simply like this: A plus B, A plus B, A plus B, whole star. Mod 3 is equals to 0 for the alphabet AB. So we are write like this. We will write like this, and simply mod 3 is equals to 1. How we are going to make it? Mod 3 is equals to 1. How we are going to make it? Because mod 3 is equals to 1, so we are going to write like this: A plus B, A plus B, A plus B, and A plus B. Because 3 is equals to 1, so 1 is always there, that's why rest can be star, but 1 is always there. Or we can write like this, A plus B, A plus B, A plus B, A plus B, star. Either it can be at the end, it can be at the starting. Or next, how we are going to write 3x plus 2? 3x plus 2. For 3x plus 2, how we are going to write regular expression? We will write like this: A plus B, 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 like this. 3x plus 2, this is 3x, this is for 3x, this is for 2. Or we can write like this in the same, this is the same, we can write like this also: A plus B, A plus B, A plus B, A plus B, or A plus B. Either on the left hand side, other half can be left and half can be on the right hand side. Or we can write like this also: A plus B, A plus B, A plus B, A plus B, A plus B. We can write like this also. This is for 3x plus 2. Either all on the left hand side or on the right hand side, or half on the left hand side, half on the right hand side. This is for 3x, this is for 2. And a few more important things are left. What they are: if language is ambiguous, then all grammar regarding it will be ambiguous. If language is ambiguous, then the all grammar regarding this will be ambiguous. Thus it is not possible in regular language. Thus it is not possible in regular language because we can make DFA, because we can make, because we can make, this is not possible in regular language, because we can make DFA from regular language, but NFA can be ambiguous. We can make DFA from the regular language, but NFA can be ambiguous, because as we know, we can make more than one move from one state in NFA. So we can simply say DCFL cannot ambiguous. DCFL cannot ambiguous, but some CFL can be, ambiguous. Why? Because DCFL, as we know, regular language, and it comes between regular and DCFL. That's why it cannot be ambiguous. But in CFL we have some combinations, so in some CFL can be ambiguous.